Thanks, Craig. Hi, so my name is Charles O'Farrell, as Craig mentioned. This is probably not going to be, in some ways, an exciting talk. Hopefully, we're just going to keep things really simple. So the title of the talk is Caught in a Web of Functions. So I work at Ambiata, where we like chopsticks, and you'll see a reason for that in a minute. But part of my day job is writing web applications in Haskell. So when I came to Ambiata and started writing Haskell web applications, my first question, well, what web framework should I use? Coming from a Java background, it was inconceivable to me that I could possibly do this from some simple sort of first principles. I had to kind of pick up something heavy to kind of help me along. And over the years, we can see people asking the same question on the Reddit Haskell mailing list. You know, like what should I use? How do I use it? How do I get started? Which is a fair question. My favorite question though is what Spring framework should we use for Haskell? Probably lots of XML involved in that. So I mean, there are plenty of good answers here. Some of these have been around for a while. Something like servants sort of is the new kid on the block. And all of these are the right answer or the wrong answer, depending on how you want to ask the question. So for the remainder of the talk, I want to introduce, and I do apologize for like a contrived, very simple web application, just so I can motivate some of these examples and walk through what I'm talking about. And it is a very simple example. So to sort of motivate this, I'm going to pick an arbitrary framework. Scotty is the first web framework that I used in Haskell. And it's meant to be the kind of beginner-friendly, getting started framework. So hopefully, even if you don't necessarily know Haskell, or even if you don't know Scotty, hopefully the examples in Scotty will kind of make sense. So to sort of start with, for a web application, let's just start with the kind of the route so we can kind of talk about our interface for our application. So we have sort of these three routes. We have these two pages, the login page and the kind of the profile page. And let's just step through the code for each of these examples. So the very simple bastardized HTML here is sort of this get page that returns this very simple form that when you kind of submit on the username, it will post back to itself, post back to the login page. The second page will be the actual post itself. So when you post back to this page, you want to pull out the username field from that post. You want to set the cookie to be the username itself, which is obviously not what you would normally do. And then finally, you want to redirect to that user page, or their user page. And finally, we've got the kind of the profile page itself. So we want to pull the session cookie out. It may not exist, of course, if you haven't logged in yet. So you should redirect to the login page. And if the session does exist, you should then check that the user is actually the one that they're supposed to be. And if they're not, tell them that they're not authorized to view this page. Otherwise, hello. So now that we've sort of seen a really simple example in Scotty, and that didn't look too bad. Hopefully, depending on how much web application programming you've done, that would look reasonably straightforward. I want to take a step back and kind of look at what are we talking about when we talk about web applications? What do we actually mean and what are we trying to do? At this point, I should probably draw some sort of complicated diagram, but I can't draw. So I'm just going to kind of use a really simple kind of some code on some slides. And when I'm talking about data in, data out here, this is my really bad way of sort of talking about, like, this is our logical part of the application. This is the part that talks to the database. This is the part that performs the actual calculation. And this is the function that we actually care about. But what we kind of need to do is get data into the system in some way. We need to kind of tell your program, well, this is what I'm talking about. And obviously, we might do this thing through the CLI. We might do it through HTTP. We might do it through Thrift or all of the above. So these bytes are going to be coming in, and particularly for HTTP, we're talking about some sort of HTTP spec. And these bytes are going to be streaming on some socket that we're talking about. But we really don't want to be dealing with bytes the whole time. So we need to be able to parse these bytes into something that means something to us. So let's talk about a request and response as some sort of encapsulation of these values that we then start to do something more useful. And so it's this bit that I'm interested in. So we can think about now our web application, our application as a function that basically is a request to response. Something that given an HTTP request with some values, we want to then construct an appropriate HTTP response. So in fact, in Haskell, there's a library called YOW, which stands for Web Application Interface, which contains actually these data types. So it contains a request data type that contains things that we might care about from the HTTP request, like the URL, the HTTP method, and a list of headers. And it also contains a data for response, which contains the status code, the list of headers. And both of these will contain body, but I've left them off for brevity, but also because they're a little bit more interesting. So at least from my perspective, I don't know whether people know what I'm referencing here, but there's a scene in Jurassic Park where the velociraptors are chasing after these two children. They stumble across a Unix system, and the girl explains, "This is Unix. I know this." So I think what I'm trying to say here is that when I see, or when I'm programming in Haskell at least, I try to break my problem down into these simple data types and then just write functions that compose these things. So I'm going to kind of reference this thing again and again to sort of show that this doesn't need to be complicated. We can just write simple functional programs that are just data types and then functions that manipulate those things. So now that I've introduced this simple request and response data type, let's look at how we'd actually program in this style. So this is our get route from the Scotty application from before. I just want to ignore the routes here for a second, just the path part. I just want to focus on the functions that are returning these responses. And I want to kind of suggest here that we really just want a function that returns a response. It's not taking any requests, it's not doing anything with that, it's just constructing a response to return to the browser or to the request. And so the HTML function here that we're trying to kind of construct should really just be a function that takes a byte string and constructs one of these responses. So how do we construct a response? There's a function in Y called response LBS, which takes an HTTP status, it takes a list of headers and takes a byte string and constructs the response. If you haven't seen it before or you don't know, response LBS stands for LBS stands for lazy byte string, but it's not relevant to this talk. So this is one way to construct the response in Y, and it's the only one that we're interested in today. So the other thing we'll need to do as part of this constructing this response is come up with a status. There's a library called HTTP types, which contain a whole bunch of type synonyms and ways of constructing statuses and other things around HTTP. So there's a function called status 200, which allows us to construct a 200 status. So with that simple function, or those two functions, we can construct this HTML response. It's a lazy byte string response. It's 200 status, and the content type is text HTML with the byte string body, and that's all we need. So with that in mind, we can go back to our login get function and just call our HTML function with this sort of byte string body, and we get back our login response. So I mean, this is just one example of really a very, very simple function, response LBS, and we're kind of building up combinators to kind of manipulate or construct or do something with these data types. So the second page that we had is the post login page. And so there are three functions here that we're kind of interested in kind of setting up or being able to use in our new world here. So the first one is param, and this is where I'm going to do a massive hand wave and say let's not worry about this too much, and let's assume that there's a function called param which takes sort of the name of the parameter, the request itself, and returns the byte string value of that parameter. It wouldn't actually work like this in practice, but let's not talk about that. Just to make the talk fit in the time frame. So we're going to skip ahead to the redirect function. The redirect function is going to be something that takes the sort of the URI byte string. And if, as far as we're concerned without a redirect, we really just want to construct a redirect that is a 302 status. So we can use our response LBS function from earlier, set the location header, and for now we don't need a body. And so finally, we're going to go back to the set cookie function, which is going to be a little bit different than our kind of previous constructing response functions. So rather than we've already constructed our redirect response, what we need to do is manipulate it in some way. So this function is going to take in this response and then somehow add the set cookie header. So there's a useful function in Y called map response headers, which takes the response, gives you a function that you can then manipulate by adding and removing headers, and then gives you back a new response. There's also a useful library in Hackage called cookie, which allows you to kind of render and parse these cookies. So we just want to be able to render this thing. So to kind of finish up, we want to map over this response, and given a list of headers, we just want to append this new set cookie header. So coming back to this post function from Scotty, we now see that we have all the ways of dealing with it. So we can pull out the username field from the request. We can then redirect to the user page, and then given the response that we're redirecting to, we can then add this extra set cookie header. And so that's our final function. So no magic there. It's really just these three functions that we're composing. And to kind of bang on the point a bit, it sort of really is just these these simple request and response data types that we can then build up functions for. So the final one, which looks a bit longer, but is just as easy as the other two, we can kind of look at the functions that we're kind of interested in dealing with. Starting with the get cookie function. This function will be one that takes this request. We want to then pull out a particular cookie by a certain name, and it may or may not exist. There's obviously a way to pull out the headers from the request in the Y library. There's also a useful function in the cookie library which parses a cookie header. So with those two things in mind, we can pull out the request header, pull out their headers, look up the cookie header, and then from that cookie header, if it exists, we can parse it and look up the particular name. The param function here is a little slightly different from the one before, and I want to just ignore it, but just remember that this is the one that's pulling out this sort of user field from the URL, so we'll come back to that in a minute. So finally, we need to be able to return an HTML response, and of course, there are two different types of responses here. One of those is going to have a different status. So previously, we saw that we had this HTML function that had hard-coded a 200 status function, 200 status for this response. What we actually really want to be able to do is pass in this optional status or this mandatory status and then set that instead, but of course, keep the content type HTML. So with that in mind and with these functions defined, we can then step through this quickly. We can see that we are pulling out the session cookie. It may or may not exist. If it doesn't exist, we want to go back to the login page, and that's just going to construct one of these responses. If it does exist, we want to then compare it to this user parameter that's being passed in. Again, we'll see how that happens in a second. And then finally, we can construct an HTML response with a 200 status or a 403 status, depending on what we're trying to do. So there's nothing particularly magical in there in the end. So yes, sorry, to bang on again, we really are talking about functions that are constructing and pulling values out of these requests and responses. Let's get to something slightly different now. We saw, of course, those three functions, but we need a way to kind of dispatch to them or call these functions depending on the particular request path. So this is the definition in Scotty for the kind of this sort of declarative way of saying we want to care about the login request with the get or post and the profile page with a user sort of hole. And so we need a routes function that is given this request and returns this response that we kind of want to return to the user. And there's a useful function in Y called path info, which given a request gives you the list of segments. So this is the part between the slashes in your request. Now, of course, there might be kind of lots of different ways of doing this particular routing, but the simplest that I can think of to show on this slide is basically pattern matching. So we're going to call path info on this request, and we're going to pattern match on the kind of the list of segments. So of course, if it's just login, it's the login page, and if it's the profile page, there'll also be an extra kind of free variable called user that we can then pass on. So the interesting thing happens at this point if we actually try to compile this code in Haskell, which is that depending on your compile flags, you may get a warning saying, well, hang on, there's a third case here that you haven't thought about. So we've dealt with the two cases that we care about, but of course there's a third, which is that if you go back to the Scotty application and try to run it, you're going to get a 404 page looking something like this. It's not very useful. If you're like me and you came from a kind of Java background, this might look familiar to you. This is the default like Tomcat 404 page. And if you come from sort of the .NET world, there might be a similar IIS 404 page. But of course, a 404 page is a critical part of your application, just like any of your other pages, just like your login page and just like your profile page. And this is the example of the GitHub's 404 page. And it's something that obviously contains useful information, and it's something that you expect your users to see at some point. I'm sure we've all seen this at some stage. So of course, in our kind of contrived example, of course, I don't really care what happens, but I am forced to think about this. I am forced to return a response. So I'm just going to return HTML of 404. And along the way, of course, as our application gets more interesting, it may be that we call this getUser function that's going to return a possibility of a user not existing. And if it doesn't exist, we kind of then need to return possibly the same or a different 404 page. And because these are just functions and because we're just doing our normal thing, we can then just extract a function called notFound, which returns a response, and we can share this function across multiple different places. And so yet again, we're seeing that the sort of very, very simple use cases of functions and data can kind of build up this application without too much trouble. So the last piece of the puzzle for this routing is the method, like the get and the post. So there's a function called request method on Y. We can then sort of, just to make this look similar to the Scotty example, one way of doing this would be to pattern match on the tuple of both the method and the path info. And we can kind of see that we have our final routes function, which kind of, if it's a get login, you can see us dispatching or just basically returning the response for these different things, passing in the requests where needed and passing in the user value from the get profile page. And of course, the difference here being that we actually care about the not found route, so we have to kind of think about that here. So as part of doing this, one thing that you may or may not have noticed kind of in comparison to the Scotty example is something that I'll mention now, which is that obviously we care about the safety of our programs, and what was interesting with the pattern matching example was we pulled out this free user variable and passed it on to our user get function. That was something that was kind of, it fell out of pattern matching. But if we go back to the Scotty example here for a second, we can see that there's sort of this, I think it's a Sinatra kind of URL type string, and it's sort of declaring that this user part of the URL is something we care about, and we'll pull it out. But of course, it's not surprising that you can actually get these two values out of sync, and then you get some horrible 5 or 100 error in Scotty, which should never happen if you've ever tested your web application. Now, there's a cottage industry of type-safe web routing libraries in Haskell, most of which I haven't necessarily used, but it's interesting to see that there are so many of them. And I want to try kind of a thought experiment here where, given our kind of routing function that we have here, I kind of want to, the core essence of this function is something that I want to keep, which is the fact that it's just a request to response function. This is our application, and I should be able to kind of dispatch to these different login and user functions that just take this request and return this response. So one that I found interesting was the YOW routing library, which I've never used before, but it's interesting that just by kind of passing it this list of routes, by kind of declaring that the particular function is a get or a post, and then using what I quite like as this applicative style of building up the routes and then passing the values into these functions, I can then build up the routes in the same way, but the important part is I'm keeping this sort of the request to response essence of this particular function. So coming back to the chopsticks, this is one of the things that we like at Ambiata, a whole bunch of different reasons. One of them, which is that they're symmetrical, but also in this particular case, I think is the fact that we can kind of take a different chopstick and kind of keep using them. Like our functions are kind of reusable and composable in this way. So now that we've seen building up this very, very, very simple request to response function, the question now is like, how is this useful? How do I actually keep running it? So we saw, an application really is this request to response function. It would be nice, like in that diagram earlier where I showed the kind of the bytes coming in, the bytes going out, we need some library that will take in our request to response function, open up a whole bunch of sockets, make sure that it parses the HTTP request and turns it into one of these requests and then takes the response and returns it on a socket. And in fact, this function does exist and exists in a library called warp. It's not the only web server in Haskell, but it's usually the most common, and it's a really good library. It does exactly what I just described. So to actually kind of then call our routing function that we had earlier, we can call run with a port number 8080 here, and then as the requests come in over the socket, we kind of get parsed and turned into the request here, and then we can do, call our normal function as is. It's interesting to note that Scotty, by default, has a function for running it like this. Scotty M was sort of the routing function that we saw earlier and takes the port. But in fact, Scotty exposes another function, which is just this sort of Scotty M to IO application. So in fact, at the end of the day, really, our Scotty application really was just this Y application. So using Scotty was just a means to kind of construct one of these functions. That's really, at the end of the day, all we cared about, which was this request to response. So I've told a small fib along the way, and I just to kind of partly for convenience, but I just want to kind of clear it up before we finish up. Previously, we thought about this application as this request to response function, which is obviously a convenient way of thinking about it. But if you've ever written a Haskell application before, and we need to do some sort of database, talk to a database or talk to another server or read some files on disk, of course, it's quite likely or very, very likely that you'll actually want to have some sort of I/O involved. So in fact, we should be thinking more about this application as a request to I/O response. And at the end here, we can kind of do some database stuff in the middle, but then return this pure response to the server. But of course, actually, this is not quite true in Y. This is something like, this is one way to think about it, but in fact, Y has a slightly different representation of application, which is a slightly more complicated signature, which is an application is something that's given a request, but it's also given this extra function callback that I've called respond, which is a function which takes a response and returns IO of response received. Response received is not something you construct manually. It's only possible through the web server, so you're kind of forced to, at some level, pass the response to this function before you finish up. So you can see the last thing I have to do is pass it the response that I'm constructing. At the end of the talk, I have a link to a slide or a post that's really good and walks through the kind of why this is and explains in good detail what the sort of the reasons for this are. So just to kind of wrap it up, we started with the question, what is a web application? Like when we think about writing web applications in Haskell, how complicated does it need to be? And at the end of it, we saw the useful Y library to kind of break it down as a request to response. We saw that we can define these request and response as simple data types in Haskell. we saw some useful web libraries like Y, but also HTTP types and cookie, and there's a whole bunch of other libraries that can be useful depending on what you're trying to do, that it kind of manipulate or do things with these data types like request and response, something like HTTP media or Y extra. We saw that something like pattern matching in Haskell is a really useful way to kind of get some safety in your program by sort of having certain states in your program not be considered. The pattern match will tell you that you haven't considered them. And we saw that having a 404 page in your web application is just as important as any other page in your application, so that having something like pattern match exposed, that is really good, but also if you're using a library, it's important that your library is giving you a 404, like giving you the chance or forcing you to think about your 404. It shouldn't be making an implicit decision for you. And we saw that a function should be composable and reusable in different ways, so that I shouldn't be kind of picking up a library that then forces me to rewrite the entire application just so that I can make something a little bit different. And so we started with the question, like, what web framework should I use? And I hope this talk isn't necessarily about you should use Y or you shouldn't use Y, you shouldn't use Scotty. It's really just about the fact that our functional programming in Haskell and different languages should be as simple as breaking our domain model up into these data types like request and response, and then writing functions just to manipulate those in different ways. And so some resources that you might find useful. The first one is a link to this to a GitHub repository that has both these slides, but also both a Y and a Scotty example that you can run and kind of play around if you're interested. The second link is a link to the blog post that talks about the Y sort of response and the reasons for why it has that extra callback, and it's really good. The third is just a talk that's very similar to this, which is kind of starting from scratch and using Y to kind of build up a web application. Thanks for your time.